Hey everybody, this is Alex Merced, and welcome to another episode of Web and Data Interviews with Alex Merced. And today our guest is going to be Ray Riga. Now, before we get started, I'd love you to introduce yourself. Talk us to a little bit about like your career and sort of where you got started and how you kind of got to where you are now.
Yeah, great. Alex, thank you so much for having me on. I appreciate the opportunity. I have about 7 years of data engineering experience, and I first started at a wonderful ed tech startup called Newzella. And they were the ones that transformed me from a back-end Python and SQL developer into their first data engineer. And so that was where I got to even just learn about the data stack in the first place, that there was a difference between, OLAP and OLTP, for example. And so having seen over the last 10 years how things have evolved since then is really exciting to me. And I look forward to discussing it with you today.
Got it. And basically, what are some of the now? Actually, let's just talk about what is data engineering. So, when for those who may not be as familiar with that space, listening, just how would you describe data engineering, and how does that differ than being like sort of like a back end developer?
Sure, great question. Um, there's a lot of day to day sort of boots on the ground or in the weeds or however you want to put it differences that I think we can get into a little later. But I would say at the highest level, I think of data engineering um, sort of just like any other value added part of a supply chain in any business. So in any time you're doing a value add, you have some raw materials you take in, you transform them into something more valuable, and then you go provide that to whoever those consumers are. So in data engineering, the raw materials are data from all kinds of sources, structured data, unstructured data, semi-structured data. That means everything from like a spreadsheet to a novel to a video, so all that data, you don't know what to do with it after you have a certain amount. Once you have a quantity that is unmanageable, that's when you need the value add of data engineering. We come in, we gather all that data, we transform it into more useful forms that non-technical business users and data analysts and to other technical users can access to gain insights, actionable insights, and do their best data-driven work.
Got it. Okay, and then nowadays, sort of, wait, tell us like sort of like the technologies that you used then, and sort of like how the technologies you've used for doing like different types of data engineering work has kind of evolved over the years.
Sure. So the first data stack that I worked on was within the AWS cloud, and so we were using something called Redshift. That's a massively parallel processing, column-oriented uh, data warehouse. And so I learned all about the great benefits of column-oriented data stores at that time. And writ large, it's just that it's much better at all kinds of aggregation. So the things that we want to do on the analysis side, a column of data is literally stored on disk together. So if you want to know the min or max or sum or average or whatever it is of that column, it's trivial from a speaking data at that low level. And then we had to figure out how to get the data we wanted into Redshift properly. And for that, we were using um, kind of the first modern generation of workflow orchestration tools. So back then, I was looking at both Airflow and something called Luigi, which were both open source Python, directed acyclic graph DAG workflow orchestration systems that were pretty well tuned to our needs at that time for ETL, extract, transform, load operations. And so we ended up selecting it actually back then, Luigi, because it had a built in Redshift integration before Airflow, going way back in history. After that, my career transitioned a little bit, and I did get my hands on Airflow, and I'd say that is the system that I've worked most with for that. And I overall am a fan of it. And I've worked with a bunch of other cloud-based data warehouses like Google BigQuery and also Snowflake, which is a standalone software as a service. All of these give you the ability to use the same SQL that you're already familiar with from Postgres or SQL Server, MySQL, whatever, Oracle, MySQL, whatever. And so that is something for me as I transition. They're like, well, if you're pretty good at SQL, you should get really good at it, and then you'll be a really good data engineer. That was really, for me, the common thread that ran through all those years of data engineering, those things I mentioned. So working with a data warehouse that where SQL was the native language to use. Also using a workflow orchestration system of some kind for the extract and what turned into more of an ELT, extract, load, transform over time, than an ETL process that we were doing, and Python. Python is the language that I'd used and that most of the systems spoke. Obviously, we can run Python jobs in Airflow, and that you write those jobs in Python and so forth. So I have taken a hiatus from that career for a couple of years, and in that time, as I was finishing out those 7 years, it was really the data lake was the buzzword and the new thing that was kind of coming out. And I had looked at that and been like, well, that seems okay to me, but we're having enough trouble with governance and auditability and things like that with our data warehouse. We have to document everything, every single change. We don't have the type of things that we had on the back end, building in Python and Django, for example, where we had schema migrations and obviously Git version control for every change. And the changes we were making in Redshift or Snowflake or BigQuery, we weren't using, Ansible to make those, to like write those, author those changes. Like those were humans making those changes. And if any human didn't perfectly document the change, then we had a little bit of a black box on our hands of how did things get this way? Who made it them this way? So that was one of the pain points. In this intervening time, I've discovered the data lakehouse paradigm.
So tell us about
So
that. So what is the data
yeah,
lake house? What makes it different than what came before?
so so I already kind of laid out what the data warehouse is. It's something like a database, but it's just much. I'm talking like hundreds or thousands of times faster than your database at doing those aggregations. The idea of a data lake was that was kind of the when sort of no SQL was the flavor of the month. So there were these like ways to interact with data in your S3 compatible object storage, right? But you were going to have to learn some DSL, some domain specific language to within some no SQL framework to do that. For me, I was kind of like, well, I just spent all this. It was more of even just inertia. Like, I want to just keep speaking SQL. I don't know that I can really like do this other thing that well. And also, like, I don't know that I see it being as proven, robust, things like this. The idea of a data lakehouse is to really get the best of both worlds, where you're not paying extra for this fancy, massively parallel processing, column-oriented data warehouse. One of the pains of that is that a lot of times you're paying for metered usage, and it gets very expensive the more you use it. The flat storage is much cheaper, but then you have all these problems of organizing, accessing that data governance, all those other same pain points that I mentioned. The data lakehouse creates this software application that runs literally like a house by the lake. Like if you have a lake of data, you can have this little house next to that lake, and you have a boat to go out in that lake and you can explore it and so on and so forth. And what you do in that house is you keep records of everything going on with that lake. You are the steward of the lake in the house. And so you keep track of who added the data, when. You keep track of what changes happened to the data. How do we change it back? Just like what I mentioned, Git version control. We never had that in either of the other paradigms. Now we do. Saying also schema evolution, we call it over here instead of schema migrations. It means that every time we make a change to the structure of the tables in the data warehouse or whatever you want to call it, we are just like with Git, we're able to roll back and forward every single change we ever made instead of what I said, having humans do it in a way that needs to be manually documented in an unreliable, human error prone fashion.
Got it. And
And then,
oh,
yeah, yeah.
yeah, just to kind of just follow up on that, like basically, when you so basically what you're doing is you're creating like a data warehouse like experience, but on top of your data lake. And in that, like, what kind of projects have you been sort of using this experience? What tools have you used in doing so? Yeah, tell us a little bit about that experience.
Sure. So for me, I've been working as an entrepreneur and I've just hit a point with my venture where I have too much data to manually sift through anymore. For example, I do some events. I do event planning. I have an event mailing list of about, 1,500 emails now. And so maybe I'll send out 5 emails per event we do, a campaign. And then I use SendGrid. And then I have an account with SendGrid where I can export all my email activity.
Mm-hmm.
I export all that. I have over 50,000 rows of activity data now. That includes all the opens in, atomically every single time they opened and all the link clicks, all the every time. That's very good engagement data. I can go back there and say, who are the people that are really looking? Who are the people engaging with the content that I'm sending out? But I can't do that manually. So that's why I was like, you know what? It's time for me to reach back into this tool set. And now is a great time to try out this new paradigm of the data lakehouse. For me, I'm a scrappy entrepreneur. I don't have a bunch of money to throw at this problem right now. So I was like, let me see if I can find something open source, something I could run on my own laptop, ideally. I don't have to pay for any cloud, anything. I have all the data on my laptop right now. I don't even need to put it in I don't need to pay for object storage, ideally. And so I tried out a couple of different open source platforms. I tried one called Trino, and I just unfortunately wasn't able to get everything orchestrated properly DevOps wise on my machine to get that really running. And then I found Dremio also, and I gave that a try. Luckily, thanks, really praise due to you, Alex. I was able, using some blog posts and tutorials that you've made available on the internet, to successfully get this Dremio, Minio, and Nessie and Spark stack running on my laptop. And so, really, honestly, it's been my first time really getting my hands dirty with PySpark, and it's been like a cakewalk. I'm like, oh, so you're telling me I just go over here and I write some Python code? Okay, that sounds familiar. Like, and then it runs very quickly, and I can use that to do my sort of initial data cleaning on the way in, like just normalizing the column names, stripping white space, making sure that all the columns are conformant, to a spec, things like that before we load them in, right? Can do all that stuff. And then I can literally, with a new data set, just magically create the table from Spark over in Dremio. It's an incredible, it's just a very streamlined experience for me so far. And then once you have it in Dremio, then you're building. It goes back to the same experience I had with Redshift and Snowflake and the others. You're basically going through a medallion process, a medallion schema process, where you are trying to set these different levels of data transformation and cleanliness, working up to what you would call your gold level, which is the data that's ready for your end users.
Hmm.
And so doing that in Dremio is amazing because you're really just creating what I would call materialized views uh, in the old paradigm, and I believe we call it reflections in Dremio, where you can get these massively performant gold tables in sort of a surgically specified way. And to me, and as you're making all these changes, I mean, they're all being tracked just like Git. I mean, and then I can go back, I can, using Nessie, I can go back into previous commits and see what the data looked like at any time. I can't tell you how many times as a data engineer, something wasn't right. A lot of times, also in that old paradigm, we'd have multiple sources of truth within the organization. A lot of times you had data scientists, machine learning people being like, no, we need it on flat object storage. And the rest of the company being like, well, we like our data warehouse. And then you'd be basically trying to keep this data synced up in those two versions of the truth. Anytime that didn't match, those data science things, sometimes those didn't get up to the C level for weeks, you know? Then weeks later, we have someone at the C level, another couple days down, message comes back down to us. Why don't these reports match what we've been looking at in our, whatever it is, Tableau, Periscope, Looker, whatever their data visualization tool they have, right? Um, what did the data look like 3 weeks ago when it was loaded for the data for the scientists and machine learning engineers? And then I was had to be in a position to deliver be the bearer of bad news and say, well, you know what? Our backup retention for that system is only a week because it's very expensive. So I literally can't tell you. My magic time machine only goes back 1 week. I can't tell you what the data looked like 3 weeks ago.
Hmm.
So to me, having the benefits of this are just numerous. And I literally have been able to take those 50,000 rows of data, pre-process them in Spark, load them with, you know, in a turnkey way into Dremio, meaning I didn't have to go in and write the spec for what the column should be and what the column type should be and all that stuff. I didn't have to do any of that. I just got the data, I loaded it in, Dremio figured out what the DDL should be
Hmm.
and everything else, and made that data source there. And then I went on top of that and I said, okay, let's filter out all the duplicate data. Now let's get out the data that isn't links and clicks. Now I have just the links and clicks now, or opens and link clicks, I should say. And now let's group those and let me sort them and show me my most engaged mailing list people. And I have it. Now for events, I'm like, oh, wait a second, that person might be a sponsor for an event. If they're that engaged with it, I'm going to work, I'm going to try to get a meeting with them personally.
Nice.
On
Now,
the another front, I'm trying to find investors. So I'm doing all kinds of emails out to potential angel investors. Apply all the same stuff I just said to that. Out of these 3,000 angel investors that I've been able to gather their information over the last year, who should I be spending more time on individually following up with? And if I can go see who's most engaged with the emails I've been sending out, I don't have any better guide than that.
nice. And then one thing I just do want to point out is just that like, very I find your particular application and usage of like this sort of like Lakehouse setup very very fascinating. But one of the things like they'll point out is that the reason why like Dremio was able to sort of just immediately pick up on these tables is mainly because you're using a format called Apache Iceberg. So basically, this creates sort of this like sort of uniform, universal way the data can be represented. So technically, when you're using Spark, you're writing that data over to MinIO, and all the actual physical data is being stored on MinIO. But then you have Nessie which is aware that these tables are written to MinIO, and then then Dremio connects to Nessie, and Nessie then relays to Dremio. Is like, hey, here are the tables that exist, and theoretically, any other tool, like you mentioned, Trino, Snowflake, other tools could connect to that Nessie catalog and then be able to operate on those same tables, which is one of the most beautiful parts of the Lakehouse, where basically is you're not like you're not locked into one sort of set of tools. So you can use that same data across all these tools, and they can all see each other's changes. And as you mentioned, when you're particularly using like the Nessie catalog, it has like that Git like versioning, so you can track like now like when the changes happen and who made those changes, which is pretty cool. So overall, very 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 cool experience. And and then so far, like uh has it been like a bit easier to kind of identify like sort of like you mentioned, like potential investors, potential event partners, stuff like that?
Yeah, I mean, you know, I've it's a part of my workflow now. It's basically an essential part of my workflow already. I don't. Again, it really was just kind of like taking shots in the dark otherwise, and so spray and pray kind of stuff. Now I can actually feel like I'm spending my time in the most valuable and most effective and way possible where I'm going to get the results I'm looking for. And that combined with some other things I've been doing for my business, like I recently had a big pivot where I changed the mission of my venture and completely redid the pitch deck and everything else. So having that combined with this info of who's already maybe a little bit curious and maybe has a little, wants to learn a little more. Now I kind of am like, well, these are the people that I need to make sure that I talk to in person, and we see if there's any synergies here.
Awesome. And on, oh, I was just about to ask. Well, okay, well, one, like if you were to talk to somebody right now who kind of wants to get into the space, sort of like, hey, what should they consume? What should they learn about? What would you recommend?
Yeah, I mean, to me, like it's something that I have like the whole for me. It's probably been over a year that I was like, oh, I have this goal of like transitioning into using the data lakehouse paradigm, and I need to really wrap my head around it more. So I've been looking at a few different solutions for that and for my business. And we already mentioned Dremio and Trino. Obviously, another big player in the space is Databricks Delta Lake. And so I've looked at that stuff and I played with all of them. And for my particular needs, I do think Dremio is the best way to learn. I think the work stuff that you put out and really just um, having it be open source and that you can run it locally with Docker Compose. I mean, that is really a low barrier to entry. Um, if you are someone that's more like cloud oriented, I know you could do that on Dremio too. I think also Databricks does have some very good educational resources. I think you could probably explore either one of those avenues, whatever one seems more germane to your needs. Um, and I just think that getting your hands a little bit wet in it is the way to go. Once you start using this, I mean, it's really a game changer, for me as an experienced data engineer. If you're first getting into it, I think that it really doesn't make sense to learn that much about the old ways. I mean, this is the way to go. Like, start here.
And now, as you go through your startup journey, where's a good place for people to be able to follow your journey and kind of see what you're working on and just kind of follow you in general?
So I have a website, a personal website. It's rayriga.com, RAYRIGA.com. So that is where that's kind of my little link tree area where I'll let you know the different things that I'm working on. And certainly, you can find me on LinkedIn if you just look up my name. And you'll see that if you know Alex, we're connected, so that you'll know that's how you know that it's me. I'd be happy to talk to anyone that wants to really kick around the ideas of data lakehouse for your business, of sort of reskilling a team that is working with the old paradigm. It doesn't really take that much. It's really just it's mostly just conceptual and some slight workflow tweaks, and then you get so much value. So please, yeah, I'm happy to just speak directly with folks that are really that interested in this.
Awesome. I just want to first off say thank you, Ray, for being on the show, and I look forward to hearing how your journey continues to move forward and sort of how your stack evolves over time. But really awesome to kind of see that sort of like that application of these technologies kind of in sort of that on your laptop kind of way, where it's basically, hey, really showing you that like you could be at any scale, and the data lakehouse is a paradigm that can really be providing a lot of value.
Yeah. Thanks so much for having me, Alex. It's been a pleasure.